So, hello everyone, I'm Brigita. I'm the last presenter, so I'll try not to hold you back. And we already have 3 minutes upfront schedule, so maybe I will save another 3 ones. So my topic is actually about sentiment analysis of Lithuanian online reviews. And we specifically started to analyze large language models. So I'm not going to go into agenda. We will see it through the presentation. So the general objectives are the increased demand for automated solutions when analyzing sentiments in our online shops, e-commerces. This is the increasing and ever-growing platform in our world. We are not really seeing any much less demand. It's always increasing. Much more people are leaving the reviews, leaving the comments, and everything goes to the online shoppings, online procedures and products. So this is just every day we receive more information on the internet, and getting this information in your head by people analyzing this manually is becoming almost impossible. So this problem has been analyzed for quite some time. The first papers had been released in 2002, I believe, and initially this was classified as the classical classification problem for analyzing and classifying text. But these NLP problem solutions never predicted and created quite improvement results. This text classification problem was actually really changed approach when the transformer architecture models were introduced, and this significantly enhanced the results. And when talking about the analysis and the sentiment analysis, there is a lot of research done in English, and there is some research done in Chinese and some specific languages, but actually there was a really little knowledge of the large language models and the Lithuanian sentiment analysis task. So at first glance, this looks like a very simple problem, but there's always some nuances when analyzing text. And we need to understand that the sentiment itself is very broad scope. And when we are talking about sentiments, like according to the Webster's dictionary, sentiment has more than 5 or 8 synonyms of it. So we can classify it as emotion, as a view, feeling, opinion. And this is a very broad scope. So in our terms, we are trying to minimize the problem that we are trying to solve. And when we analyze on sentiments, there is always some challenges that are coming up when trying to understand the text. And there's always some subjectivity that involves identifying whether the text is actually subjective or objective. There is some difference in the sentiment understanding itself. As I said, some can have the opinions, some can have the emotions, and sometimes subjective opinions may not convey any emotions at all. They can be just a statement. And maybe there can be also an emotional text, but it could lack the sentiment itself. So there are various approaches to tackling this task, but in our scope, we analyzing the 5 category sentiments based on emotionally and rationally positive and negative comments. So we analyzed most used classical classification large language models, and we chose to fine-tune and work with BERT and T5 models. So both of the models were initially pre-trained on multilingual data, but the T5 model had some advantage over it because we took already fine-tuned data, already fine-tuned model on 100 hours Lithuanian specific articles. So this was done previously by our colleague Lukas, who created some specific work around grammatical error corrections. So this actually gave some advantages to the T5 model. It's also worth mentioning that these models are quite different in the scope of their parameters. So these large language models had already big base on them and had quite a huge parameters. So for all the experiments, we used the gradient paper space workshop, and we used machines that had 45 and 60 gigabytes of RAM. So each of these training data sets are actually quite computational expensive. And for the data set, so we didn't took any public data set, we collected the data ourselves, and the data collection was created from free Lithuanian public data sources. So it included like news internet research, and the largest data set, over 90% of data is actually collected from the Google Maps reviews. So initially we collected over 130,000 reviews. But after some cleanups, like removing the, I don't know, only smiley faces and empty comments, we were left with 120,000 reviews. And it's worth mentioning that we didn't do any lemmatization, any pre-processing for the data itself. Large language models are known to be capable of capturing the real emotions and the real parts of the text. They tend to perform better when there is no data pre-processing done by humans before. So we split the data set into two data sets to compare the results, and one was initially with all the data that we gathered, and the second one was actually had a little bit bigger more equal distribution around categories. So the problem is that when we're trying to take the comments, there is a really usual distribution of that people tend to leave the reviews on very excited and happy customers, and also the ones that were really dissatisfied. So it's really hard to collect something that is like rationally negative, like the category that you would express your self-emotion as a 2. So these are the data that was really missing in our experiments. So for the results, when we are talking about the final results, D5 model could actually outperform BERT in a small scope, but in the testing data set, it actually performed a little bit better. Both of these models tended to actually fit to the data quite easily. Even when we are talking about a data set that contains over 100,000 of entries, it's actually still quite relatively small for the models like these. But considering the data structure, we don't have any specific domain knowledge. We don't have any specific context to the data entries. The results were quite promising for the initial experiments. It's when we are looking at the data, it's really hard sometimes to understand what is neutral, what is positive, especially when we are talking about the subjective emotions, and when we don't have additional context about what this person is talking about. So even for a person itself, it can be quite a challenging task to try and categorize this data. So for the discussion part, actually, when we've done the initial overview of our results, we can see that the context of pre-training data is one of the most important parts. Even if we are trying to support the model for a specific task, it's really greatly improved the results if the model already has the general understanding, better general understanding on Lithuanian data. Only multilingual data sets isn't enough, and having the understanding and trying to capture the main context of the text, the semantics and the lexical, graphical things of Lithuanian language can greatly improve the results. This was the problem also that we encountered, that there aren't that many monolingual, actually we couldn't find any monolingual Lithuanian LLMs that could be available and modified in the future. And the third part that I encountered as myself for the problem was that when I wanted to create data augmentation that are done with the general approaches when we want to increase the data set. There aren't any public Lithuanian resources that could be used for the sentiment word change, that we could increase the smaller scope categories. So this could potentially increase our results if we could create a useful dictionary that can be used for data augmentation. And for the conclusions, actually 5-label sentiment classification remains quite challenging task. When we try to reuse these models for classifying the results up to 3 categories, positive, neutral, and negative, the results increase significantly. We reach 82% accuracy, and this is quite different from what we have like 56, 57, when we are trying to categorize the 5 categories, and fine-tuned T5 model outperformed actually BERT. So we do have the conclusion that it's actually helpful to have the pre-trained Lithuanian monolingual model, and for the future work, of course, as most of these works include, we should have the better dataset quality, size, and further model fine-tuning could be done to improve our prediction outcomes. So thank you for your attention.